Hey, what's up, players? Shikara and I back again, and we're ready to tear into another pop, another server drop. And this one, we're going to be tackling Mnemonic, I believe is how you say it, from TryHackMe. Very cool stuff. This one's an interesting one. It's a little bit lengthy, but we're going to go ahead and explain some of these things. Now, if you're new to the channel, and you're new to my series, Pop, another server drop, it's essentially where I use capture the flags environments to teach some basic hacking techniques. And I don't tend to go through and just barrel through and just show all the commands I'm doing and just leave it at that. I like to take these as an opportunity to kind of discuss the methodology behind what I'm doing, why I'm running certain commands, looking up help files for the commands to understand what the switches are doing so that we don't turn into some kind of skitty, and we don't want that, right? Script kiddie, for those that aren't familiar with that term. We want to essentially know exactly what we're doing, how it's happening, what the switches are for, those sort of things. So I usually take a little bit slower approach to these and kind of explain step by step what's going on. Also, if you see my other videos in my series, you'll note that I do repeat myself at the beginning for a variety of different things, like port scanning and things like that. And that's just with the intention that maybe you as a new user maybe not have seen my other videos. So I don't want to I want them to be self-contained. I don't want them to be dependent on you watching all of my other videos to understand the things I'm saying. So if you've heard it before, oh well, it's all good, right? You can hear it again, and then I'll just kind of explain as I go what we're doing here. With this TryHackMe site, they don't endorse me or pay me or do anything like that. I like going to this site, and I think, in my opinion, the best way to learn hacking techniques to be an ethical hacker, which is what we're shooting for, the best way to do it, I believe, is to do these capture the flags. Now, while they may not be completely true to life of real life environments, they do teach concepts, they do teach methodologies for cybersecurity. So they're excellent in doing that sort of thing, and also getting to know your different tools and different commands and trying some different things. So these are all self-contained within TryHackMe. I do pay for the $10 a month one to get all of the rooms plus the browser-based Kali. Those are pretty handy to have. I'm using a virtual machine right now with Kali to run this particular one, so I don't use their attack box, but once you do pay for this sort of thing, you'll be able to start your own attack box, which will be there already built into the browser. It's all self-contained. In my opinion, this is one of the best sites for capture the flag to use. I know there's other ones out there like Hack the Box and other things like that. This is the one I'm most pleased with, I guess you could say, when it comes to that. So I always tend to use my Pop series with these particular ones. All right, so we're going to use this as a kind of a guide to kind of see, kind of lead us through what we want to do with this capture the flag, but we're going to explain a few different things. So the first thing they want to do is they want to enumerate. And that's one of the big key things when you're doing ethical hacking. If you ever take the OSCP course, the Offensive Security Professional one there, that's going to be the majority of that exam is going to be enumeration. It's very important. And one of the more common ways you would enumerate is with a tool called Nmap. Now, you see here I've got the IP address of the attack machine. I've already started it. And what I did is I already started running the command ahead of time because I know this one in particular will take a while. So I didn't want to take up screen time with it. But let me explain what's going on here. So with port scanning, essentially a port would be a way into a machine. Okay, so you have 65,535 what they call TCP ports and UDP ports. TCP and UDP are what they call transport protocols. Think of it as a truck delivering packages. For example, if I want to have all of my, let's say I had 10 packages and I work in a shipping and receiving dock, the truck comes in and he says, all right, we got package 1 of 10, 2 of 10. Hey, we're missing 3 of 10. I'm not pleased with that. I want my whole order. So I'm going to tell the cat, go back and get my other package. And so that player will come back with it and everything's good. But it takes a little bit more time because they got to go all the way back and get it and come back. But I have a complete order. This is an example of TCP saying the data packets that are going in to this quote unquote truck are going to be reliable because I'm always going to make sure I have all the packets and it's going to be a reliable one, but it may be slower. Whereas UDP it doesn't really care about that. It's Fast and the Furious, you know what I'm saying? Vin Diesel down the road, 100 miles an hour, packages are falling out the back. We don't care. We just want speed. How quick can I get my packets there, even though I don't have all the packets? So what? That's usually typically used for like streaming and VoIP and things like that. So in this case, there are 65,535 ports, but they're both TCP and UDP. Now, there are some that are marked as what they call well-known ports, and that's the first 0 through 1023, giving it essentially 1024. And those would be things like SSH port 22, TCP, HTTP port 80, HTTPS 443. Those are ones that are already carved out by the powers that be, like IANA or whoever, I don't know what it is, IETF or whoever they are. They basically say, all right, these are ports, are standard ports. You do not need to type in the IP address : port. Normally you would have to, if it's not a well-known port, then you would do it that route. But now people can just type in google.com and go directly to it because it just assumes 443 in this case here. So those are well-known. Then after that, you have what they call registered ports. And so from 1024 or 1025 on up to around, I'm going to say around maybe 49,000-ish. Those are what they call registered ports, and those would be like a company makes, like maybe Citrix makes a particular device, and they say, we want to have it always run on port blah, blah, blah. So they register with the IANA, I believe it is, to have that particular port reserved for Citrix, right? What is it? Microsoft's SQL Server, 1433, 1434, right? Those are registered ports for that software. Then from 49,000-ish on up to 65,535 are what they call dynamic ports. And these are the ones that get opened when you communicate with another machine. So if I want to communicate with server A from my client, server A is probably listening on port 80, right? Maybe it's a web server. And I'm coming out of my machine on a random port up in the 49,000 to 65,535 port range. So when we do port scanning, our idea is on our attack machine, our target, we want to find out, is there any ports open? What is actually on that machine? Because if I can see port 22, I can say, all right, well, SSH is running on it. If I see port 80, I know there's a web server on it, right? That's the idea with port scanning, and the tool of choice for most is Nmap. So in this case, you'll see some switches here. Now, when I say TAC, I mean dash. So when I say TAC, so here I'm going to do Nmap TAC N. So the N in this case here would mean the, and by the way, let me show you this real quick because I don't want you to turn it into a skitty. So I want you to make sure you understand the man page. So you can say man Nmap like that. And it will show you the manual page, and you can go down through and see all the options that I'm going to talk about here. Now, this is a pretty long file, so I'm not going to go over all of this. I'm just going to kind of explain what each switch does, but I want you to look at this on your own time and look down through and just verify what I'm telling you, because you never just want to take word for it. You want to always make sure that, you know, it's what you know by looking at the actual content. So in this case here, what I've done is I've run Nmap TAC N, and what that's saying is disable DNS resolution. And that kind of speeds things up for me a little bit because I don't have to worry about it trying to resolve the DNS name because I'm doing it based off of an IP address. TAC capital PN will be for skipping pinging. And the reason I would want to do that is if you do an Nmap scan and it comes up with no results, but you know there's something there, it's likely that they've disabled ICMP and do not allow pinging to those servers. Therefore, the Nmap scan will end and you won't have any results. So skipping pinging will make sure I don't try to ping and see if it's alive because I assume it is. I know the IP address in this case, right? That's only if you're doing like a ping sweep. Then you get attack capital A, and what this one does is called the aggressive scan. Now, if you're trying to be stealthy and do a pen test against your company or a company, you don't necessarily want to use this one because it's pretty noisy, and the defense team, the blue team, will probably see that traffic because it does a lot of different things. The default scan mode for Nmap is called stealth scan, S capital S. and that's only if you're running it as root. So in this case, TAC capital A would do 4 different things. One, it will do a version scan, S capital V. And what that will do is it will compare signatures of what it's seeing as it's probing the services that are running on there against a particular text file that it has of known signatures of different software. If it kind of pokes and prods at it and returns a signature that matches VSFTPD 3.0.3, then it will return back saying, yeah, we have good confidence that what's running on that port is this. So we'll do a version scan, which is dash or TAC S capital V. Then it will do a operating system scan to verify what the operating system is with pretty good certainty, and that's a TAC capital O if you're doing the regular switch. Then it will do a default script scan, and there's a variety of scripts that come with Nmap. And if you want to do ones that are in a category they call default, which are not intrusive and not going to bring down a system, then it will run all the scripts in there. One of those scripts, for example, is this one right there. Okay, so that's a script that we actually have. I'm sorry. Yeah, that's one. That's one of the script names right there. Okay, here's another script name in the default category, so on and so forth. So it's going to run all those that are in that particular category. And then last, it will run a trace route. The TAC will say that it's going to scan for all 65,535 TCP and UDP ports. Well, I'm sorry, let me rephrase that. All TCP ports. So by default, Nmap will only scan TCP ports by default. If you're looking for an SNMP port 161 UDP, you'll actually have to specify S capital U, then the port you're looking for, because by default Nmap does not scan, doesn't scan anything up but TCP. Also by default, if you don't change anything or add any switches, it will scan the first 1,000 top well-known ports. Now in this particular case, because this challenge wants to know the SSH number, which I found out was this number. So previous run, I saw that it was not running on the standard port of 22. 22 is the port normally used for SSH. However, you can run it on different ports, but it's not the normal port. So because I knew that was the case, and I knew the first 1,000 common ports were going to be scanned, I decided to do the TAC to make sure I get that in my scan results. So that will scan all of them. It takes a lot longer, but it is what it is. So doing that, we see they have FTP open. We see they have port 80. And there's a robots.txt file. What this file is it appends. It's in the web root of whoever running the web server. And what they will do is they'll put directories in here that they don't want bots to crawl in their indexing. So bots being like Googlebot or Bingbot or what have you, they're saying, hey, when you get to my site to crawl, look at the robots.txt file, and that's what it has to be named. And I want you to look at the paths, and the ones that I'm disallowing, I don't want you to crawl. So to an attacker, they're going to think, interesting, why don't you want me to crawl that particular URL? So those are the paths that we are looking for. In this case, we see there is a disallowed entry of webmasters. So sounds like an interesting path that we should be checking out. Then down here, you also see that they are running SSH, but it's on a non-standard port, as in not 22. So we'll keep note of that. So yeah, there are 3 ports open, and that's what we put here. And then the standard, the SSH port listed there. And it's saying here, what is the name of the secret file? So how do we come across that? Well, we have a tool that we can use called Gobuster that I like to use. There's other ones like Dirbuster and such, but it's what they call directory busting. And the idea is that you have a word list of all of these paths that are common, like /admin, /wp-admin, whatever it may be, /backups, whatever. Those are going to be in a big list, and it's just going to try them one after the other. Now, to speed things up a little bit, we already know there is a /webmasters folder. So we don't actually want to do our Dirbuster, in this case, from this IP address alone. We want to do this IP address /webmasters so we can see what's in that particular path for any directories that we want to see as listed. So in that particular case, I'm going to use my sweet, awesome Dratus, as you guys have seen me use before, because I don't like typing everything. So we're going to go ahead and use Gobuster. dir says do a directory scan or directory busting. TACU is for the actual URL, in this case here being the server that we're the target. And then we're also going to be using the /webmasters with it. The TACW is pointing to a word list that I want to use of common path names. And there is one under Derby, and I'm using Kali Linux. So this path may be different for you if you're using a different OS. But for me, this is where this file is located. So let's go ahead and grab this real quick. And we'll need to modify something real quick. So we're going to change the IP address to the IP address of the attacking machine. I'm sorry, the target machine. So in this case, we know that it is that address right there. Boom. All right, let's see what we can see here. So what it's doing now, it's using Gobuster to go down through and blast all these different ones that are in this list to see if anything comes up. And look at that. /admin, /backups. I don't think we need to go any further. Let's Control-C out of that. All right, so we have a /admin. That sounds pretty awesome. Let's see what's going on there. Let's see if anything good's going on. So we'll put in the IP address, /admin. Okay, not found. All right, interesting. How about, what was the other one? Backups? Backups? Not found. Interesting. Oh, you know why? Because we didn't put the webmasters. So webmasters /admin. Let's try that again. All right. So we got an admin page that has nothing on it, I guess. Nope. Okay. So let's try the backup one. Backups, I think it was called. Is it backups or backup? Let's see. Interesting. So we see backups as listed there. All right, well, let's do this then. Since we don't see anything directly in that route, let's do this. Let's do another Gobuster, but we'll do it starting from backups. So we'll go ahead and run the same one again. This time we'll do it from starting our Gobuster from backups. Now, what we'll also do is we'll actually add in something called TACX. Now, again, I want to make sure we don't turn into skitties. So let's go ahead and man Gobuster to verify what I'm doing here. Really? No Gobuster. Let's try Gobuster TACH. There we go. So TACH would be for the help file, as you can probably imagine. So yeah, we're using dir. You can see there's other functions that it does do. In this case, we're using it for directory busting. In this case, we don't see what we want to see here. Let's see. Interesting. Let's see if there's a manual page. Should be a manual page, I would think, for Gobuster. So we'll say Gobuster manual. We'll say man page. Let's see if there's one out there. All right, so interesting why it's not actually in there. But anyways, regardless. Let's see if we see what we have here. So we know we had the dir. We know the TACU was for the URL right here. Target URL. All right, here. This is the one we want. File extensions. So TACX will give us where we can list a bunch of different file extensions that we want to look for. And this is only in dir mode, which is what we're doing. So let's come on back here. And what we want to do is we want to go ahead and... Am I doing the wrong one? Sorry, this one. So what we want to do is add in some common extensions that we would know for backup files, like BAK, comma, zip, comma, tar, you know, those sort of things. Let's stay with that for now. So we're looking in backups for directory busting, and using our word list, we want to go ahead and say, use the words that are in the word list, but then append the extension .back to it, .zip, and .tar. So let's do that and see what happens. All right, so we have some HTA stuff with the tar. We get the zip, we get the back. And these are common ones. Again, you can list any ones you want in there. Just do a comma separating each one of them. But we're We don't really see what we want out of this right yet, other than just the htpass WD kind of stuff here. But this is a great tool to use. And again, you can use any tool you want for this sort of thing. You can use Burp Suite Intruder for it, and you can also use Gobuster. All right, looks like we got something there. Backups.zip. Interesting. So let's Control-C out of that. So we now know there is actually a backups.zip location. So let's go ahead and use wget, and let's grab that file. And let me grab the IP address here. So we know it's under, keep going to the wrong window. There we go. And we know it's under /webmasters/backups. And we know it is backups.zip. So, you know what? Before I do that, let's go ahead and make a directory to put these in here. So let me just copy this for a second. And let me back this up for a moment. I have my TryHackMe folder. Let's make a directory called Mnemonic, I believe is how you spell it. There we go. And let's cd over to that. Now let's go ahead and run our command. Awesome. So we now have a backups.zip. So let's go ahead and unzip that. Ah, it's password protected. They fooled us. So in this case here, we can use a tool to kind of get around this called zip to John. So what we want to do is we want to locate where that's at if you have John the Ripper installed. I'm going to say zip to John. It's a particular, I think it's a Python script. Yep, there we go. So what we want to do is we want to run this particular file. And what this will do is we'll go ahead and say, what is it, backups.zip. And we want to put this, this bracket means output to a file. So what we want to do is put it into a format that John the Ripper can crack, which is what this zip to John does. So it'll take a zip file and make it into a format that it's able to go ahead and crack. We'll just call it, you can call it anything you want. I'll just say pop.hash. Sounds good? All right, so now we can see it says here is not encrypted, backups is not encrypted. Well, let's verify that it did actually do fill. Okay, so it did fill it with content, so it did do it. I don't know why it's giving that error, but anyways. So next we will use John the Ripper. So let's go ahead and use John, and we'll pop it against that. So we'll say pop.hash, and we're gonna use our word list equals. So again, John the Ripper, if you look at the man page, you'll see tac word list, or TAC-W, I think it is, for whatever the word list is you want to use. And we'll go ahead and just use the one under this location. And again, if you're using something not Kali, you won't have this exact same path, but wherever you've installed this one here. I prefer to use rocky.txt. It's one of the more common ones, and pretty awesome stuff. Now, I had already previously done this with kind of testing for this particular video. And so it actually populated in something called john.pot. So whenever you crack something successfully with John the Ripper, it'll record all of the different ones that you've cracked, essentially, in a file called john.pot. For instance, if you locate john.pot, you'll see that's where it's located. So I've already done this with this file. If you've already done it with this pop.hash, then you just say john pop.hash tac show to show what the results were from that. In this particular case, this right here would be the password that we gleaned from it. So we now know that is the password for doing the unzipping. So now that we have that, let's go ahead and now and unzip backups.zip. And we now know the password. Let's put that in. Bing. All right. So it looks like it went ahead and put a file under backups/note.txt. So if we look here under ls, there's our backups folder. So we navigate over to that. And we have a note.txt. Let's take a pop and see what that says. Cat. Cat is a command in Linux. If you're not familiar with it, that will print whatever's in a text file onto the screen. So that's what we'll use. All right, looks like we have a user guy, a username called James. Let's remember that. And we have an FTP username. We do know FTP is open, so therefore we now know the username. However, we don't know the password. So there is a tool that you can use for that sort of thing called Hydra. Okay, so Hydra, let's go over here and we'll say man Hydra. Hail Hydra! So in this case here, we're going to use this tool because it allows it to go ahead and brute force protocols, right, or different services and protocols. In this case, we want to brute force FTP. So here we can see, as we scroll down, there's a lot of different options. Now, we do happen to know the username, which is FTP user, right? Because we just saw that in the note. Therefore, case sensitivity is key here. See the TAC little case L? That means I do know the actual login name. Now it says here, TAC capital L, file login. In other words, we don't know the username and we have a word list of usernames that I want to run it through. We would use TAC capital L for that. We're not doing that because we know the username. However, we do not know the password, so we can't use the lowercase p. We have to use the uppercase P, okay? And we also will be blasting FTP, which I believe is listed here. Yep, right there, FTP as one of the ones that it does blast. So let's go ahead and quit on out of that. Let's blast back on over here. All right, so we're going to use Hydra, and we're going to say TAC L, little case L, FTP user, and then we'll do a TAC capital P, and again, we'll use our tried and true rocku.txt. And I'm not very good at typing, so sorry. And then we're going to say FTP : / and then whatever our IP address is. Right there. And, whoops. That's not the address. Why did it not copy? Copied. There we go. All right, let's try that again. So let's FTP over to... Doggone it. Strange. All right, no big deal. Let's go ahead and grab what we know is that. Let's try it again. There we go. Now we're playing with power. All right. So in this particular one here, we'll go ahead and run this attack against FTP, and we'll try brute forcing against that list that we have, trying every possible iteration of it from that word list, one after the other. With the free version of Hydra, it is limited in its speed as far as what it can do, but you can also kind of speed things up by doing a -T, which is for threads, and you can indicate how many threads you want to assign to doing this particular password crack, and that would be advantageous in this case here. But this one's not really a difficult password, so it shouldn't take entirely long. But what I'm going to do here real quick is just pause the video so that we're not waiting all day here on this in the video. And then we'll come back when we actually have the password cracked. See you in a minute. All right, looks like we found what we wanted. Love forever. Oh, how sweet. So it looks like that is the FTP for it. So yeah, let's pop on over and let's do FTP into this bad boy and see what we can see. All right, let me grab that actual address again. Awesome. So now it's asking for the name we know is FTP user. And we now know the password is love forever. Awesome. So let's do an ls tac l. See what we have. All right. Directory listing. Data 1, data 10, data 2, data 3. All right. Let's see. Well, that's a lot of directories. Okay. So this is odd. There's a 4 there while everybody else has a 2. So maybe that's something we should look at. Let's take a look and see what's in there. So we'll say ls data -4. Interesting. Look at that. So we have a couple files here. Let's go navigate over there. Data -4. All right. ID underscore RSA. What this tells me, likely, is this cat here. Who was it? James, was it? The name that we had found? I think it was James. this is possibly his SSH private key. So when you use SSH, you have a thing they call asymmetric encryption, where you have a public key and a private key. The public key is available to everybody. The private key you keep obviously to yourself, as they have here in this case. And whatever the public key does, the private key undoes. And whatever the private key does, the public key undoes. And you typically use that private key encrypting type of scenario for something called digital signatures. But in this case, we know that this key pair will actually be for SSH, meaning we're not going to need to know the password for James's SSH because we have the private key. We can put it in something they call interactive mode. I'm trying to remember, I believe that's what it's called, interactive mode. So if we man SSH, I think TACI is the one I'm thinking about. Oh, I'm sorry, identity file, that's what they call it, identity file. So TACI would be the one that we would use to actually, mess with it. But the key thing to remember is it will give you an error if you use that TACI if you don't set the proper permissions on it. Because if you're overly permissive with it, as in full 777 permissions, and watch my Linux videos for more detail about how Linux permissions work, you want to make it not as permissive. So 600 is sufficient. So we'll have to do that. But anyways, let's go ahead and grab these and we'll put them here. Let's see. ID_RSA. We'll get that. So the get command in FTP is what gets the file, as you can imagine. Not.txt. I don't know what that is, but let's go ahead and grab that as well. Awesome. So I think we have all we need from FTP. And let's go ahead and cat that not.txt. I'm curious. James, change your FTP user password. All right, so we can kind of assume James is the guy. This is our huckleberry that we want here. So let's go ahead and do a chmod. What this will do is this will change permissions for this. Now, if you ever look up anything about chmod, and again, I'll just briefly touch on this, but I did a whole video on Linux basics. But if you look up the chmod permissions, they have a couple ways they can do it, like +X for executable or add an executable, or they do an octal or number. I think that's what you call it, octal. And there's certain ones like for read only and for everything else. And I'm trying to see if that's in this very first one that we're looking at here. All right, here we go. So 6. 6 right here would be the one that's not overly permissive, whereas 7 is overly permissive. So in this particular case, I would want to kind of change it to read-write only for this particular one. So the 600, when I come up with the word 600, with the number 600, 6 would be the first entry. So let me look over here and show you what I'm talking about. So if we actually look at, let's do ls tac-l. There we go. So we can see ID RSA right here. Now, the first dash you see here tells me it's a file. If it was a D, it would be a directory. And then you have the next 3. RW, R means read, W means write, and X would mean execute. In this case, we only have read-write privileges, so we're already pretty good to go, I think. I don't think we'll need to actually change this. And then the next 3, the first 3 are for what they call owner of the file. And in this case here, the next one would be for the group that the person's in. And then this one here is for everybody else. So I don't believe we'll actually have to worry about that, but let's see what happens. So we'll do a SSH TACI, and we'll point to the ID_RSA, and then we'll say James @ So when you do an SSH, the command syntax is the username, @ symbol, and then the IP address of the machine that you're actually tapping into. So in this case here, let me grab the IP address. And the SSH TACI, in this case being, I'm pointing to an actual private key. If I didn't have the private key and I knew the password, I would just say SSH James @ IP address. But in this case, we don't need that. So let's go ahead and see what happens. Can't connect to host. Interesting. Let's verify our host is up and running. It is. Let's try that again. That is the correct IP address. Connection refused. All right, well, let's ping. Make sure we're still alive. Okay, we are. Interesting. So I wonder. See if I'm missing anything. I always kind of go back to my cheat sheet to verify I'm not missing anything. Oh, that's right. It's on port 1337. Yeah. Come on, Ray. Get with it. So we know from our Nmap scan prior that the port number was 1337. So that's why. That's what we're missing here. So let's go ahead and do this again. This time we'll actually add in the TAC P1337. There we go. Okay, so whenever you do this SSH stuff, it'll ask you if you want to accept and use this digital signature for this, and you have to type in yes or no. I'll say yes. Ooh, this one is password protected as well. Oh, interesting. Bad permissions. Okay, so that's not good. Bad permissions. All right, here's what we'll do. So we know that this one also does need a password, apparently. So we can use another tool from John the Ripper called SSH to John, I believe it's called. So locate SSH to John, and it's very similar in its concept of the one we did prior, which was the zip one. So again, we're going to be making an SSH ID RSA private key into a format that John the Ripper can crack. So in this case here, we'll go ahead and grab this location to run it. It is a Python script. I don't believe I'll need to do Python before it, but we'll see what happens. So in this case here, we're going to say, what was it called? ID underscore RSA. And then we're going to go ahead and pop it out to, we'll just say pop2.hash. All right, did it do it? I assume it did. So let's go ahead and then John the Ripper this bad boy. So it is pop2.hash. And we will then again use the word list equals. And we'll use RockU as well. Awesome. All right, look at that. Ooh, that was quick. Blue love. So it looks like it found it automatically. So nothing too difficult there. So we can assume then that James's password is that. And for some reason, it was giving me, it was still giving me an error right here about it being too permissive. So I'm going to go ahead and change that. Instead of 600, we'll do 400, which I believe is just the read-only access. So we're going to change that file ID. Let's see, say chmod 400 ID underscore RSA. Awesome. So now if we do an ls-tac-l, we can see it only has read permission and there's no other permissions for anybody else. All right, let's try it again. So now we're going to go ahead, SSH tac-i, and we'll do our ID underscore RSA. Let's not forget our port. And then we'll say James at, oh, I really need to put this down. It actually worked last time, so let's try it again and see if it does this time. Copied, cool. And let's go ahead and, there we go. Awesome. All right, so it doesn't give me any errors or anything like that, but we now know the password is blue love. Blue love. Yes. Awesome. So I guess you have to enter it in twice. One to decrypt the actual ID RSA, and it's also the same password he's using to log into SS. Ooh, what happened? IDS system on, unauthorized access detected. Ooh. Looks like it caught us. Are we able to do anything? Let's see. Nope, I guess not. Interesting. Oh, wait a minute. Are we in? Oh, no, we're still in. But it caught me. So what happened? No, we are in. Okay, let's just verify. Let's do an ID. Okay, we are in as James. So what was that all about? Okay, anyways, looks like we got a couple files here. Let's see what these are all about here. Let's cat 6450.txt. Interesting. That was a bunch of numbers. Let's do this. Let me put this into a file. That is odd. I don't really know what this is all about, but I'm going to grab it anyways. And I'm going to put it on my own desktop here. So let's see here. Let's navigate into my Mnemonic folder. Let us do a nano and what was it called? 6450.txt. And I'm going to paste in all that business. All right, cool. So we have that. I don't really know what that's all about, but let's go ahead back and see if we can find some more information. What was the other one called? Note for James. So cat note. Ooh, I guess it doesn't do tab complete. Okay. Cat note for James dot txt. All right, note for James. James, I found a new encryption image-based name is Mnemonic. Interesting. Name of the actual CTF. I created the Condor password. Don't forget the beers on Saturday. Okay. So, a couple things. Obviously, we have something called Mnemonic, which is an image-based encryption of some sort. And then we have some guy named Condor. So we know there's that. Let's go ahead and Google this Mnemonic deal here and see what's going on. So it said it was image-based encryption. So we'll say image crypto Mnemonic. Hey, it's almost like I typed this in before. Hey, look at that. So mnemonic cryptography. Interesting. What is this? Users added a picture. Anything can happen in Mnemonic. It takes the pixel values of the entered image and calculates it, creates a special access code from the picture. Because the values of each picture will be different, so in decryption, you should only have the same picture. Note, use an image higher than 72 dpi. Bada bing, bada boom. All right, so it looks like we have to install this bad boy. So let's go ahead and do that real quick. See what this thing is all about. All right, very cool. And install colored. Okay, and because this is a Python script, it looks like these are all these different requirements we need for Python. And we also will need to clone this bad boy into this directory. So, all right, so I think we got all the requirements. Next, what we're going to do is we're going to go ahead and clone this directory into here. So we'll say git clone the IP address of that GitHub page, and then we'll go ahead and navigate over into it. All right, so there is our Python script. Let's go ahead and run it, see what happens. I believe Python 3 was probably what we're going to use. Let's see what happens. All right, access code image file path. Okay, I don't have an image file. That's a little odd. Let's go back here. All right. Are we in as James or no? Did we lose it? I think we lost it. System block in. Yep, it did. It knocked me out. Look at that. Let's try it again. Let's try SSH back in there again. Blue love, right? So it looks like the IDS knocked us out. Okay, so we already know that there is some stuff here. No for James. Okay, let's see if there's any hidden files. So we're going to do an lstack LA. Nothing there. Though there was a guy named Condor, right? So let's see what's under home. Look at that. There's a Condor. Okay, so can we navigate there? Let's see what happens. And we don't have much time because it's going to go ahead and kick us out eventually. Oh, it's restricted. Okay, well, let us see if we can see what's inside of this cat's location. Huh, interesting. What is all this? Okay, this looks like base 64. Let's grab this for a second. That's interesting. No, we don't want that. Let's open up another window. Let's try to base 64 decode this. So what I'm going to do is I'm going to say echo. And essentially, if you just do echo and then whatever you want it to echo like that, it will just echo it in the next line. But if I want it actually to pipe it or send the output of it to another tool, then I would use something called a pipe symbol, in this case like that. So it looks like if we do the pipe symbol, we can send it to something called base 64 decode, and the -D is for decoded. So I'm saying echo this value, base 64 tac D, and look at that. So we already have a flag for our capture the flag. Pretty sweet. Do I have that in here? I don't have that in here. There it is right there. Which one is that? Let's see, A5F. Okay, looks like that's the user text file. All right, cool. So we already have that. All right, let's see what the other one is. This one right here. So we're going to do the same thing. We'll echo, but this time we'll go ahead and change it to the new one that we just want to check. There we go. Let's try that. Ah, interesting. Look at this. It's a URL to an image. Go figure. Awesome. Well, let's grab that then. So we'll copy that. And let's go ahead and navigate over to my folder. And let's go ahead and wget whatever that image is. Bing. All right. So wget obviously is a command line version to download something. So we have this maxresdefault.jpg. Now, I do remember this was asking for a file path for an image. I'm assuming this is the image. So it'll be under /root/TryHackMe. And it was called, what was it called? maxresdefault.jpg. Okay, that's strange. Process completed. Image analysis completed successfully. Your special code is... Okay. So I'm assuming we want to decrypt this. Let's do 2. 2 for decrypt. Encrypt message to what file path? Now, it's possible that the numbers that I had pulled in the other text file are what we would use here. Let's see. See if we have any indication. Okay, so all these different numbers, I'm assuming are color codes. So my guess is what they're doing here is the key file, the actual seed file is probably the other one that we had. What was it called? 6450, this one here. It's probably using that as a seed file. So let's try that. So root, TryHackMe. And it was called 6450. All right, let's see if that's... Look at that. Boom. That's crazy. It's a pretty cool little encryption deal. It's called Mnemonic, and there's our password. What if misspelled, but either way. So I'm guessing... let's see. What does that go to? Let's go ahead and look up here. Let's see. We did this. We did this. Okay, we got the password. Okay, Condor password. Ah, okay, so that's Condor's password. So does that mean we can sudo over or switch user to Condor? I think we can. Let's try it. Oop, we got blasted by the IDS again. So let's get back in there. I'm trying to remember all these different passwords. Is it Blue Love? Yep. Okay, let's go ahead and see if we can switch user to Condor. What happened? Okay, there it is again. Let's try it again. SU Condor. Okay. Let me think here. So if we... Maybe if we just SSH in as Condor? Possibly? Let's try it. Let's see what happens. So we'll say SSH Condor at... Doggone it. And we'll grab the IP address. Because we do know the password. Oh, that's right. It's on port 1337, right? TACP 1337. Okay, password. So we do know the password. Where is it? Here it is. Boom! Pop, pop, pop. Doing good, doing good. All right, let's ID and see what we have here. All right, he's a standard user. The only one we're looking for now is the root flag. We can see this cat does not actually is not actually root. It's a standard user, 1000. Root would be considered 0. So what we can do is we can see if he has any sudo privileges. Sudo would be similar to if you're a Windows person, like run as admin type of thing. So let's see what we can do with that. So if you type in sudo tackl, this is going to list any of the permissions that he has if he has sudo privileges at all. And we'll paste in our password. All right, it looks like we have something here. So Condor may run the following commands on Mnemonic as root. So it looks like this right there can do he can run Python, and he can run this. Let's see what the permission levels are on this one. So ls tackl. Okay, so it is a root program, and we need the root password. So therefore, I'm assuming this code can do something for us, but let's go ahead and see what it actually does. Really? Are we doing a block already? Doggone it. They're gonna block us, ain't they? Yep, kick us out. All right. So let me just go ahead and stop that for them, and we'll try it again. So we need to be quick apparently about this. Doggone it. I already canceled out, player. All right, we'll give it a second here to kick us out. So we need to be super quick about this, apparently. Bye-bye. Yeah, bye-bye. Okay. So we know the path. Oh, man. I'm trying to remember now. Come on. Really? All right. Well, wait a minute. Are we still in? Wait a minute. We're still in. So why does it say bye-bye? All right. Anyways, I don't understand what's going on there. All right. This is weird. So let's go ahead and cat this bin example code. I want to see what's in there, so we can kind of get an idea what's going on. All right. Let's see here. All right. So this Python script, information system script beta. OS system. Okay, so it looks like a lot of these are running OS systems. So I'm guessing our goal will be to somehow take advantage of the fact that they're calling a shell. Now for root, we would want the bin bash shell, right? So I wonder if we can, let's look down through this and see if we can maybe do something with this OS system. So it says if select equals 1, then do this command. Okay, so it already tells what it's going to do. If I select 2, it's going to run that command. If I select 3, that command. 4, Okay, what's this one? Select 0. Okay, string input. So right here, it's telling us input. So for Python, what this is telling us is it's saying, make this a string value input. Are you sure you want to quit? So in this case here, it's either saying yes. I guess that's really the only option they're giving you. But there is two if statements below. Now, if statements in scripting means if this is true, do this. If not, or else if, do this. So here we're seeing if the person actually types in a period, then print OS system, and then it's waiting for input. If yes, exit out. Okay, so we don't want to do yes, but apparently if we type in period, it will be saying this, and it will ask for input, and OS system will run whatever that input is. Oh, here we go. That's a huckleberry. So essentially, we want our input to be bin bash /bin/bash, and that will give us hopefully root. So I guess we want to select 0. Oh, okay. So I guess this is what will display, and it was this one here, right? So we don't want to hit yes. We want to hit a period, I guess, is what we want to do. So, yeah, cool. So what was the, I'm trying to remember now, which Python version. Okay, Python 3. So we're going to do Python 3 /bin/example code.py. Cool. Running. All right. So we want to select 0, all right? Are you sure you want to quit? So we don't want to type yes because that will run the sysexit. If we type period, it should give us a running and pause there waiting for my input. And my input will be /bin bash so I can pop another server drop. So let's go ahead and do period. Running. Okay. How about a nice game of chess? Bin bash. Okay. Why is it not letting me see the other commands? All right, let's see. Shall quit, period. Does there need to be another period there? Let me ponder that for a second here. So I think, oh, actually, you know what? If we have to run this as sudo, I think. Okay, so I'm not running it as root because I didn't do the sudo before it. Okay, maybe that's it. Let's try that. So we'll say sudo Python 3 /bin/example code.py. Let's see what happens now. Okay. Yeah, okay. This is probably what the issue was. So let's do 0. No, we don't want to quit. Let's do a period. And let's try bin bash now. Ooh, there we go. Yep, that was it. Boom! Pop, 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 another server drop. So what happened there is I actually ran it as the standard user Condor because I didn't put sudo before the Python 3 command. And that was my permission level, was to be able to do that. So yeah, okay, so that makes sense. So now that we actually are root, we can essentially look under root, see what's there. I'm assuming there's a flag file of some sort. There it is. So let's go ahead and cat /root/root.txt. Congratulations, you made it. Hash me. Anyways, whoo, that was a bear. So that was a pretty crazy one there, pretty lengthy. But we did it, man. Pop, 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 another server drop. We dropped this monkey like it was nothing. and had a few hiccups along the way, but it's all good. So we learned some good things here. We learned some cool password cracking stuff with Hydra and SSH to John, FTP, let's see, what was it, zip to John, those sort of things. Pretty cool little program called Mnemonic. Never heard of that. That was kind of an interesting little deal there, using image codes or something like that for cryptography, but pretty cool stuff. So we learned quite a few on that. So I hope you guys enjoyed that video. We're going to do some more of these in the upcoming weeks for pop, another server drop. So I hope you guys enjoy the channel and the content. If you do, consider subscribing and hitting the bell notification. I try to put out videos, maybe 2 at the max, maybe 3 per week if I can. And I have a variety of other different series like Intel Bytes and some tooling ones in this pop series as well. So I hope you guys will go ahead and consider subscribing and give me some comments, give me some feedback, what you guys like, what you don't like about it. Until next time, peace out, players.